Hi, welcome to this presentation on writing procedures for scientific experiments. Writing procedures is one of our IB criterion, one of our skills that we're developing in this class, and in this unit you'll have several opportunities to write procedures. Basically, when we write a procedure, we're outlining how we would go about collecting data to answer a scientific question. The important thing to remember there is that scientists are doing experiments in order to find out what the relationship is between two variables. They want to find out how one variable affects the other. Now, variables can be lots of different things. Here's an example. We could ask a question about the distribution of quagga mussels. Quagga mussels are the invasive species that we talked about in Unit 1, and we could look at a variety of factors that might affect their distribution or where they're found. One factor might be the amount of phytoplankton. Quagga mussels eat phytoplankton, and so therefore we could wonder if the density or the amount of phytoplankton in the water affects the number of quagga mussels that we find in a given area. Scientific questions are usually phrased in this kind of format. How does the independent variable affect the dependent variable in a specific context? So in our example, we could think about how the phytoplankton density, the amount of phytoplankton, affects the distribution of quagga mussels in the littoral zone of the Great Lakes. Littoral zone just means sort of in the shallow area near the shore. And if we were to identify our variables here, we could look at the number of phytoplankton per liter of water at 1.5 meters of depth. We could take some water samples and collect that data. For our dependent variable then, we could look at the number of quagga mussels on the bottom per meter squared. So basically we're looking at what is the relationship between the number of phytoplankton per liter and the number of quagga mussels that we find in that area. So the procedure then is basically just our way of collecting that data. And in a procedure, there are a few things that are really important. One is that you do have to know what your variables are. And in your procedure, you have to spell out very specifically how those variables will be measured and how that data will be recorded. So it's important you're thinking about units and thinking about how you're actually going to measure those variables versus just looking at random data. If we're looking at it, if we want to find out the relationship between our independent and dependent variables, then we also have to make sure that all the other variables are controlled. Other variables are just basically things that could affect our data. So everything else ideally has to stay exactly the same. In our example, we would want to think about the depth of the water in the area where we're collecting the samples. We'd want to think about perhaps the temperature of the water or other factors that could affect our data. As we design our procedure, we also need to think about collecting enough data so that we can actually answer our question. This involves thinking about the number of trials that you'll do or repetitions that you'll do as you're doing your tests, and also how accurate our measurements are. If our measurements are not very accurate, then we probably need to do a lot of trials in order to be confident in our data. Lastly, our procedure has to be safe and reasonable. We have to follow all the safety guidelines, and we have to make sure that we're reasonable in terms of the amount of time we have, the amount of space we have, the kind of materials that we have, and so forth. So if we're needing equipment that we just don't have, or if you're trying to do 100,000 trials, it's just not going to work, and you're not going to end up with reasonable results. So here's an example I'd like you to take a look at, and what you're going to ask yourself is, how could this procedure be improved? It's just a brief procedure with 4 steps, and I'd like you to pause the video and take a moment and think about what kind of things would you change in this procedure in order to make it more scientific. So here's a revised version, and you'll notice that I added a lot of detail and a lot of measurements to these instructions. So I'm getting a 250 milliliter beaker. I'm not just saying get a cup. I'm specifying the temperature of the water that I'm going to use so that it's the same for all of my trials. I don't want to use all different temperatures of water because that's a variable that could affect my data. I'm talking about how much water to use. Again, this is something that could affect my data, so I want to keep it the same every time that I do this, and so forth. I'm also specifying how to record the data, so by saying that I should record it in seconds versus minutes or milliseconds or some other unit, and also talking about how to collect that data, when to press start and when to press stop. So this is a much more specific procedure, and ideally if somebody read this, they could do it in the exact same way that I did. Here's another example. This one isn't as much a science experiment, but just thinking about how we give directions to somebody. These are directions for drawing a smiley face. Again, I'd like you to pause the video and just take a moment and think about how would you write directions on how to draw this smiley face. So here's again a version, and you can see I added a lot of detail to this. I'm talking about specific tools such as using a protractor to draw the circle so that it's actually a good circle versus just doing it freehand. I'm providing a lot of specific measurements such as the diameter of that circle and descriptions, for example making a solid black oval or using a yellow marker to fill in the entire circle. So taking a look at this procedure, this would be a lot easier for someone to follow, and I would expect that they would come up with something that's a lot closer to what I intended with the smiley face. Now they might not get it exactly, but they should be pretty darn close. So in summary, scientific experiments are asking questions to investigate the relationship between two variables. These are called independent and dependent variables, and that's really where you have to start. You have to know what your variables are, and you have to think about what are the units or how you'll measure them. As you write your procedure, you'll need to make sure that it's complete and logical, so you have all of the steps laid out so that someone could follow your exact same procedure later, including as many measurements and details as possible. So always specifying how big things are, or how far away they are, or how much to put into something, etc. You want to make sure you think about how much data you need to collect so that you can actually get reasonable results. This could include how many trials you need to do, or thinking about how accurate your measurements are. And then lastly, you have to make sure that your procedure is safe and is reasonable given the amount of space and time and materials that you have. The big question ultimately in the end is could someone do your exact experiment in the exact same way just by reading your procedure? If they couldn't, if there are things that they could do in a different way because it doesn't tell them exactly how, those are things that you should change and try to be more specific. I hope you found this presentation helpful, and good luck as you write your procedures.